Okay, let's start on up. Welcome, Casey and CDO and Cecilia and CHDO and Milagros. Thanks for logging in. This is the week 3 webinar for the elementary online statistics class. And it may seem like a lot because we have 2 chapters to do today, chapter 4 and chapter 5, but it's actually one of the easier weeks in terms of chapters. So you shouldn't be too worried that there's 2 chapters. And in fact, I want to let you know, we don't do all of chapter 4, and chapter 5 is really short. So that's the good news. We only do the first few sections, I think 3 sections of chapter 4, something like that. And we'll be talking about that. So the plan today is to go over chapter 4, which is discrete distributions, and talk about the section on the binomial distribution. And then we'll go over chapter 5, which are continuous distributions, and then talk about the uniform distribution. And my main plan today is just go over some problems, some examples that we can do. It's not quite the current event kind of thing, but it is very important to all kinds of different applications. But let me open up. Are there any questions at all that any of y'all have about anything? That could be about the project or about homework or content or anything. Any questions? It's a good time to ask. You could ask other times too. Hi Elliot, thanks for joining. Okay, if there's no questions, I'll jump in. Am I going over the test for next week? I wasn't going over the test for next week. I'll talk about that next week. Because it's not due until the week from Sunday. And we haven't had really enough material for that to talk about now. And it's also, it's different than the midterm. It's not as much material. It's online. It's just long, and you only get 1 chance per problem. That's the main difference. So it's a lot of problems, but you don't keep redoing problems. So that's the main thing about the week 4 test that you're talking about. Hopefully that makes some sense. But basically what I've done is I've taken the problems from your homeworks, the assignments, and reduced them a little bit and just combined chapters 1 through 5. Okay, it might be 6, I'm trying to remember, right? 1 through 5 or 6. And then that's what it is. So no surprises. Some of the problems you'll actually recognize, the numbers might be different. Okay, and of course everyone gets it slightly different because there's randomization going on. Does that make sense, Elliot? Okay. Any other questions? That was Casey, sorry, that asked that. Any other questions? Okay, if there aren't any questions, I'm going to jump right to working out some problems. So I have an example problem. And actually, before I do that, I think I'll talk to you about the discrete distribution in general and kind of what the purpose is. So first thing, the discrete variable is a variable at which you can list all of the possible answers, at least with ... notation. I like to think of the grammar, if you guys like English. And if it is a how many question, then it's a discrete distribution. If it's a how much question, then it's a continuous distribution. So a lot of people have the easiest time thinking of it that way. It's not perfect, but it works very well. For example, if you're talking about weight, is that a how many or how much problem question? What do you think?
How much?
Yeah, how much? You don't say how many do you weigh. That just sounds stupid, right? You say how much do you weigh? So that's a continuous distribution, not a discrete distribution. And 4 is discrete. Chapter 4 is discrete. Chapter 5 is continuous. I'm kind of going over both at once. Does that make some sense? Okay. Whereas if I say how many siblings are in your family, that's a how many question, right? It's how many siblings. Or let's suppose we talk about units that you're taking in college right now. Discrete or continuous? What do y'all think? Yeah, that's discrete, as Cecilia said, because you would say, how many units are you taking? And you might say, I'm taking 12 units. Does that make sense? Continuous means that you can have any possible fraction in between the high and the low. Okay, so that would be like time taken in the shower. Okay, I took a shower this morning, and I took 12.35721,476 minutes to take my shower. Okay, I know it's hard to calculate that, but that's possible. So that's definitely a how much. So if you measure it, then we consider it being a continuous. If you count it, then it's considered being a discrete. Does that make some sense? And we're going to be working on discrete distributions. And in particular, what we're going to be looking at are what's called a probability distribution table. Because if we can list all the values, then you can list the values and their probabilities. Does that make some sense? If you can't list the values, then you're not going to be able to make a table because you can't list them. So with the discrete distribution, we'll be able to list all the probabilities, and we'll be able to list all the values and make a table out of it. All right, so let's jump on to an example. Again, I've talked enough theory. Today's not really a current event kind of day, as you'll see. It's very applicable, but it's not like in the news. But it's day-to-day stuff. Okay, especially, actually I'm going to say in any subject, in any of your majors, almost. Okay, so let me share my screen. And let me go find it. That one. There we go. Okay, so here's the question. A car salesperson gives out a $10 gift to every customer who drives a car. Okay, so that happens sometimes. You go to the dealer, and as a little perk, they give you something to get you in to test drive. You ever seen that before? Might have heard of it. Okay. 12% of all customers who test drive a car purchases the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Write down the probability distribution function for the salesperson's profit, find the expected value and standard deviation, and interpret the expected value. And then, is this a lucrative job? So let me go ahead and go through each of the steps. The first step is we are supposed to write a probability distribution table. What that means is we're supposed to make a table such that we have 2 rows or 2 columns. It doesn't matter if we make it vertical or horizontal, where the first, I'll make it horizontal. So let's do that. Do this, a couple more things. And that so we can all see. Okay. Oops, too small. That works. Okay, so what we're going to do is we are going to make a table like this. Not that easy to draw on the computer, but I'm doing my best. Okay, and in particular, hopefully that'll work. The first row is going to be X, and the second row will be P of X. And by now, I'm hoping you all know what P stands for. We've used it a lot, especially in chapter 3. I'm not seeing you all jump in at once, but hopefully, what does P stand for?
Probability. Probability.
Yeah, P stands for probability. So it's the probability that X value happens. Okay, what we want to do is we want to write down a table for the profit. So one thing you learn, anyone had a business class here? Or anywhere? And you have had a business class? Even if you haven't, you probably know this, is that if you want profit, there's a computation formula for profit. And the profit is the revenue minus the cost. How much you take in minus how much you spend. Okay, that's like really general. Most people just know that. So if you look at it, we have different things that could happen. One is the person could end up purchasing the base model of the car. Okay, so what is the profit if this customer purchases the base model? What do y'all see? Yeah, 190, because the revenue is $200, that's the commission, but they had to buy a $10 gift. So for X, make this a little smaller. For the first value of X, it's going to be 190. Any questions on that? And the probability is going to be 0.12 because that's what it says, 12%. Okay, and then similarly, if they purchase the deluxe model, then we're going to get a $290 profit, 300 minus 10. And the probability of that is supposed to be 8%, or 0.08. Something I've noticed that some people make, let's do this again, that some people like don't notice and you got to pay attention. 8% is not 0.8. Okay, you're going to move the decimal over twice. It's 0.08. Any questions on that? All right, what else could happen? Is that it? Have we dealt with every customer possible?
Not the customer who doesn't buy the car.
Yeah, they might not buy the car. What's your profit if the customer does not buy the car?
0.
Okay, I like Milagras' answer better. -10. Because you get 0 in revenue, there's a $10 cost. 0 minus 10 is -10. Does that make sense?
Yep.
So it's -10. And that's actually really important. You'll lose money. That could happen. Okay, now the next question is, what's the probability that you're going to end up with a -$10 profit? That one takes a little thinking. Yeah, it's 0.8. Because the idea is you have a 100% chance of something happening. Notice that 12% of the 190, 8% of the 290, if you add those up, you get 20%. So it's 80% more will get you the 100%. That's 0.8. Any questions on that? Okay, so what I've done now is I've drawn a probability distribution table. It's really important that you know how to do that. Notice that there's 2 rows. The first row is labeled X. The second row is labeled probability of X, or P of X. And then you write down the numbers. Any questions so far? Okay, so the next thing we need to do is we need to come up with the expected value and the standard deviation. I'm going to just show you how to do it in the calculator, and then we'll interpret it. So I'm going to pop up my calculator. So we have to crop this guy. Make a new share. Yeah, we're getting some feedback. That might be, yeah, that was phone person. Unmute if you need to, and then I'll be happy to talk to you. Okay, so you should be able to see the calculator. And what we do is we go to Stat, and then we go to Edit. If you have something in L1, erase it. And I do have something in L2, so I'm going to clear that out also. And now in L1, I'm going to put my values. The values are 180, 280, and negative 10. Notice, don't use minus, use negative. They're different. The negative's under the 3. For L2, I put the probabilities. So just like the pit table I wrote. So that was 0.12. Then we had 0.08. And then we had 0.8. Any questions so far? Next, we go ahead and I hit Stat button again. I go to Calculate and then one var stats. If you have the older style of calculator, it's just going to say one var stats. You type in second 1, comma, second 2, enter. This is a newer value type. So my list is L1. It says it, but I'm going to put it anyway. Second 1, enter. And then list 2, the freak list will be L2. So that's second 2, enter. Let me stop for a second. Are there any questions on using the calculator before I hit calculate? Not too bad. So hit enter. Okay, it gives us a lot of stuff, and really we need to focus on what we care about. And there's only 2 numbers we care about. One of them is this X bar. X bar is 36. That is the expected value. The other one is sigma X. That's the 94.57272334, or about 95. I'm going to write those down because we're going to lose them in a moment. So we have X bar equals 36, and we have sigma X, that's the standard deviation, is about 95. Any questions so far? Okay, so now let me go back to the question. And let me write down what we had. I want to go to brush, pencil. So we had the expected value, X bar, and that's really the expected value. I'm going to write EV for expected value. That's better notation. Calculator doesn't really know what we want, so it just calls it X bar. Expected value, and that was equal to 36. Any questions on that? Okay, then we had the standard deviation, which the calculator calls sigma X. I like just calling it sigma because that's what it is, a standard deviation. And that one was equal to about 95. Any questions so far? Okay, so now what I need to do, because it says I want to write down the probability distribution, I did that. I found the expected value, I did that. I found the standard deviation, I did that. And now I need to interpret the expected value and talk about, is it a lucrative job? So let's interpret the expected value. Okay, and there's some key words we got to use to interpret the expected value. Put down a bit because I have a lot of words to write. How about in green? Okay, what we can say is that if there are many customers who test drive the cars, then it is very likely that the average profit per customer will be close to the expected value, which is $36. So you need that much space. Okay, I want to note something. I want to underline because it's important and you must have these words. When you're talking about expected value, you have to use the word many. Okay, it's not just one customer, it's many, many customers. Then you have to use likely. So we don't know that the average cost will be 36. It's likely that the average, and that's another important word, will be close to $36. So those words are necessary. If you don't have those words on the midterm, for example, I will take off points. Any questions at all on what this says? Okay, let's talk about this job. What do you guys think? How long do you think it takes to test drive a car? How long do you think someone works for a car? If you were selling a car, do we have any car dealers in our group today? But how long do you think it might take to work with a potential customer on average, whether they buy it or not buy it?
Maybe like 45 minutes.
Okay, 45 minutes. I'll give you that. So if you take 45 minutes and you make $36, okay, is that a pretty good job or not? No education required, of course. You're selling cars.
Yeah,
What do you think? Huh?
Yes.
Yeah, I mean, minimum wage is what, like, not much, 12 bucks or something, 11 bucks, I don't know exactly what it is, but something like that. And you're making $36 in 45 minutes. Any questions on that? Okay. I don't know, I know when I give this, a lot of people have trouble. They don't know what the word lucrative means. That's an English word, not a math word. It means it brings in money. That's what lucrative job. It brings in lots of money. So it definitely brings in, it's a nice paying job. But now let's look at this expected value. It's 95, okay, and that's dollars. What that means is that on average, you're going to be $95 away from this $36 for each customer. So in particular, you're going to lose money sometimes. Do you see that? If you're at the job long enough, it's very, very likely you're going to make an average of $36 or close to $36. But if you're just there for the day, then you might end up with $0 in your paycheck. And that's pretty awful, right? Okay, so on average, it's lucrative, but there's a risk that you may end up losing money. So what that says that if you're going to do this as like a summer job or something, then make sure you have money in your bank account. Because you'll have days where you're actually going to end up negative. Does that make sense? So that's what the standard deviation tells us. The standard deviation is very high with respect to the mean. Do you see that? The expected value. So that tells you that it's day to day, it fluctuates a lot. That's the standard deviation. Over the long run, you're very likely to make very close to $36 per customer on average. Any questions on the idea of the expected value in the standard deviation for a probability distribution function? Any questions? Okay, let's look at another example. So last chance to erase all this. Going once, going twice, gone. Okay, let me get to the next example. I have to copy and paste that one in. Hopefully I got it. Okay, so here's the next one. You have been offered a life and dismemberment insurance policy that costs $1,000 per year. Okay, the policy pays the heirs $100,000 in the event of death and $50,000 in the event of dismemberment. Now, $50,000, you get it. Because do you guys know what dismemberment means? You know what that means? Because it's not good. My sister actually used to do this for a living, do these calculations. You don't know? Dismemberment means like you get your arm chopped off, or you lose your leg. Yeah, you lose part of your body. Okay, it's not a good thing, by the way. Okay, so it's kind of the case where if it happens, you're probably going to be out of a job, for example, really screwed up. Okay, but better than the other thing, which is death. Okay, the actuaries have determined that you have a 0.3% chance of dying this year and a 0.5% chance of dismemberment this year. Sorry if I'm like giving you depressing things, but that's kind of how life insurance policies work, right? Find the expected value and standard deviation. Interpret the expected value. Explain why the standard deviation might indicate that it might still be a good idea to, I didn't finish on the copy and paste, but purchase the policy. Any questions on this? Okay, so just like we did before, we're going to start out by drawing a probability distribution table. Ah, missed it. One more try. Gotta hit the brush. There we go. That one's a better one. Okay, so you should all know. Let me mute the phone. You should all know what goes in the top left label. What should the top left label be? You can type in the chat box. It's, yeah, X. Okay, so top left label will be an X. And the hope is you also know what will be in the bottom left label. Yeah, P of X. Okay. Just notice capital P, not lowercase p. We're going to spend a lot of time with something called the lowercase p value. So we don't want to get those mixed up. Okay, so P of X. So now we got to think, again, we want to look at the expected value, and the profit is what matters. So what is one possibility for X? Yeah, $99,000. Okay, because that means it's one of these weird things that sounds good. You know, $99,000, that insurance policy was well worth it. But why does it suck? Yeah, you died. So at least your heirs get rich. So we're looking at $99,000. And the probability of that happening is 0.3% chance. How do you write that as a decimal?
0.03?
It's actually not 0.03, but it was a good try. 0.3%. That's why I asked y'all, because I know people make mistakes. 0.003. Remember, you're moving the decimal twice. The first time you get 1 0, the second time you get another 0. Do you see that? So 0.003 will be the probability. Any questions on that? Okay. Then there's dismemberment. That is a 50,000, but you had to pay 1,000 in. So that's $49,000. And similarly, what's the probability of dismemberment?
0.005.
Yeah. So note that you moved the decimal place twice. So it's 0.005. Any questions on that? Okay, you don't want to make the little tiny like decimal move errors, or especially on the computer is going to really nail you. Okay, what else could happen?
The person doesn't have any problems.
Yeah, it's one of these weird things. You really hope you wasted your money, right? It's one of these very strange things with insurance. You never want insurance to pay off. And if there's no problems, then what is your profit? What's your profit if there's no problems?
1,000?
Not 1,000. Close. It's negative 1,000. Remember, the profit is revenue minus cost. Revenue is 0. Cost is 1,000. 0 minus 1,000 is negative 1,000. Any questions on doing that arithmetic? You could use a calculator, but you could probably do that in your head.
I think I was thinking of the insurance side.
Yeah, we're thinking about our side. We're thinking about deciding to buy the policy or not. If you did the insurance side, that's fine. You can call it 1,000, but then the 99,000 would be negative 99,000. And the 49,000 would be negative 49,000.
Yeah, that makes more sense.
You'll just get the negative answer of what we're going to end up with. Okay, then we want the probability of that happening. What is the probability of nothing happening? Yeah, CHDO 0.992. Because notice if you add these 0.003 and 0.005, you get 0.008. 1 minus that is 0.992. Any questions on that so far? Okay, let me write this down because I'm going to lose it. So we have 99,000. We have 49,000. We have negative 1,000. Then we have 0.003, 0.005, and 0.992. So now we can go to the calculator. And as you're probably noticing in this class, a calculator is essential. You do not want to do this class without a calculator. I have had students take their exam without a calculator. Guess what they got? What grade do you think they got? Any thoughts? You don't want to say it?
An F minus?
Yeah, I don't call it an F minus, but yeah.
I'm just kidding.
You cannot get better than an F without the calculator. So that's just a big note. You just need it. So let's go ahead and jump into the calculator. And that's why I recommend when you go to your test for your midterm and the final, bring some batteries too, just in case the batteries die. Okay, so here's the calculator again. I go to stat. I can do this a lot faster because it's the same as the last one. I go to calculate, then I go to var stats. I'm sorry, not calculate, I go to edit, and then enter. We'll get to calculate in a minute. I need to go up, clear, enter, right, up, clear, enter. Then I put in the numbers. And we had 99,000. We had 49,000. Then we have negative 1,000. And then our probabilities were 0.003, 0.005, and 0.992. Any questions on that? Go ahead and stat. Go to calc, var stats. L1 and L2 are just in there, and they will stay in there, by the way. That's the good news. Once you've done it once, they stay there. And I hit enter. Sorry, calculate and enter. Okay. So what do you notice about the expected value? What is the expected value?
It's negative.
Yeah, it's negative, and it's negative 450. So I'm not going to type it all out because it's the same as the last one in terms of the way you write it, but I'm going to say it. What we could say is that if many, many people go and get this life insurance policy, life and dismemberment policy, that on average, it's very likely that they will lose $450 per policy. Notice that they'll never lose exactly 450. You can't lose 450. It's an average of many people taking this policy on. Any questions on this? Okay, notice the standard deviation is incredibly high, right? It's $6,496 basically. Okay, that's huge. And that has to do with how insurance works. So yes, this is a very bad buy, negative $450. You are, on average, losing money, right? But look at the standard deviation, it's gigantic. So that's where you say, well, there's a huge fluctuation because you might die, right? It's not very likely you're going to die, but it could happen. So if it really matters about getting a whole lot of money when you die, then even though this has a negative expected value, it's still worth buying the policy. Okay? So for example, if you have a 2-year-old child, you want an insurance policy. Do you see that? Because your heirs really need you. Okay? And that's because the standard deviation is so high. Any questions on this idea? Any questions? Okay, let me go do a new share. And a new problem. How we have time? We're good. So again, we're going to lose this. There we go. And let me jump into the next problem. Let's see if it handles it. Sometimes it doesn't handle the lettering well, but we'll do the best we can. Okay, so 20% of all community college students transfer to a 4-year institution. Suppose that 50 community college students are selected at random. Find the probability that exactly 10 of them transfer to a 4-year institution. Any questions on the question? Okay, so this is a probability question, but you're not going to be able to do it using what we did in chapter 3. It's too hard. Instead, we're in chapter 4. So what we're going to know is a few things. One is that the survey question is, did you transfer to a 4-year institution? And the answer to that is either yes or no. Any questions on that? So this chapter deals, or this particular section, part of the chapter, deals with the yes-no survey question. When you have a yes-no survey question, it's typically what we call a binomial distribution. So the number of yeses and the number of nos are what's called binomially distributed. And that means, again, we want to find out how many S's we have out of a certain number. And want to find the probability of that. There's other things. There's independence that has to happen. But usually surveys like this are independent. It can't change as you talk. Like if you go through this do it over a 20-year time, it's going to change by year to year. But typically you do a survey pretty quickly. There's no problem with any of that stuff. But the yes/no question is necessary, and you're asking a sample. When you have that, we can use the binomial distribution. So first, I'm going to write down what we're going to put in the calculator, and then we'll do it. So for part A, we're going to write binom PDF. Okay, binom stands for binomial. PDF stands for probability distribution function. Okay, and that works on the exactly questions. Okay, then we're going to put in the sample size. What's the sample size? Yeah, 50. Sample size 50, because we asked 50 people. Okay, then we're going to put in the probability that they say yes. And the key is, a lot of people have trouble with this. Just because it's not written as number, like in number symbols, doesn't mean there's not a number there. What's the probability that someone says yes? It's up there. What is that probability?
0.2?
Yeah, 0.2, 20%. And then we put the number of people that we want to hear say yes. We want to find out, we want to hear 10 people say yes, because we want the probability that exactly 10 say yes. Any questions on that? All right, so now I'm going to show you how to do it in the calculator. We'll be fine. We go to our calculator. And what I'm going to do is I am going to go to the distribution button. That's second, DISTR. Any questions on that so far? Now I'm going to scroll down until I find binom PDF. And it's right here. I hit enter. Okay, the older calculators you type in as like I wrote it on the little paint board. With the newer ones, they ask you how many trials? There were 50. What was P? 0.2. What is the X value? 10. For the older ones, you type in the way I typed it in. You could go binom PDF and you type in all the numbers with commas in the middle. So who knows which one you've got. 83s do it the old way, and halfway through the production of 84s did it the old way also, and then they changed it. So now it looks like the old way, and then I hit enter. And there we go. It's about 14% chance. Any questions on that example? Okay, so let's do the next one. I don't know if I'll do all of these because we only have so much time. What's the probability at most 12 of them transfer to a four-year institution? Okay, so at most 12. What does that mean? What's the word at most mean? Yeah, 12 or less. And the good news is the calculator can handle at most. The bad news is it's the only one it can handle. So we're going to be able to do B very easily. We're going to go binom. Oh, shoot, I forgot I got it. And now it's not PDF because this is not an exactly like the other one. It's going to be CDF. That stands for cumulative density function. Okay, and then we're going to go the same couple numbers, 50, comma, 0.2, comma, and now at most 12 is 12. Any questions on that? Okay, so now let me go to the new share. And I'm going to go to second binom, second distribution, and then scroll down a bunch. And you'll find binom CDF, which is B in this case. Your calculator might have it lower or higher. I hit enter. Number of trials is still 50. P is still 0.2. The X value is 12. And I paste it in and hit enter. And there's our probability, about 81% chance. Stop me if you're not following something. Okay, now let me go to the next one. So for the next one, let me go back to Paint. At least 9 of them transfer to a 4-year institution. So again, the bad news is the calculator cannot handle at least problems. Okay, so here's what I like to do. I like to just write down some numbers here. Try this again. You can just write down 7, 8, 9, 10, 11. At least 9. What number should I circle? Yeah, 9, 10, 11. The way I like to remember is, you have to be at least 21 years old to enter this bar, right? So 21 is fine. Okay? So it starts at the number you're talking about. So what I'm going to do now is I'm going to circle 9, 10, 11. Any questions on that? And it goes farther, but that's enough for now. Okay, the calculator does not do things to the right. The calculator only does things to the left. So, any thoughts on what we can do so that we can use our calculator here?
Similar to what we do when we do 1 minus.
Yeah, we use what's called the rule of complements. And notice that if we've circled 9, 10, 11, the highest number we haven't circled is?
12.
No, we circled up there too. I didn't write those down.
Oh, the one we haven't, the highest we haven't circled is 8.
Yeah, highest we have not circled is 8. Is that clear? So what I'm going to do now is the answer is going to be 1 minus binom CDF of 50, comma, 0.2, comma, 8. Any questions on that? Okay. Hopefully by now you can do it in your calculator. I don't want to waste the time too much. But is that all right? You just type that in your calculator. You could do the binom CDF and then do 1 minus that number. All right, let's look at part D. Less than 14 of them transferred to a 4-year institution. So now what I'm going to do, again, so I'm going to just type in the numbers that are kind of close to that. How about 11, 12, 13, 14, 15, 16, 17. Now less than 14, what should I circle? What numbers are less than 14? Okay. Less than 14?
13, 12, and 11.
Yeah. 13, 12, and 11, or 11, 12, 13, either way. Okay. So now you look at it, and actually we are on the left side. Does that make sense? So actually you don't have to do the 1 minus because we're on the correct side. But the trick on this one is that our x value is 13, not 14. Because the highest number that we go up to is 13. So what we're going to do on this one, oops, one more time. Is going to be binom CDF of 50, 0.2, 13. And that'll be the answer to part D. Any questions on that? Okay, I'm going to erase it, going once, going twice. Should we select? Let me select it. There we go. Gone. And let's do the next example. And then we'll get to the next chapter. Next chapter is 1 or 2 examples is enough. Oops, missed that number. Okay, so 21.2% of high school seniors have used marijuana. A study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana. Is this statistically significant? Find the probability that at least 49 out of 200 have tried it. Any questions on that so far? Okay, so let's find that probability. Again, this is a yes or no question. Have you tried marijuana? And that high school kid is going to say yes or no. Any questions on that so far? So what we're going to do is we're going to go to, as we've seen lots of times now, and I'm going to do this somewhat pretty quickly. At least 49 starts at 49, right? So that means we're going to have to do a 1 minus binom CDF of we had 200 in the study, and then we had 0.212 for our probability. And then we want to find out at least 49. 48 is the highest number below that. 48. Any questions so far? Okay, so now what I'm going to do is go to the calculator. And I'm going to go again. You're used to this, second distribution. Go down a lot. Binom CDF. And we had 200 this time. Our P was 0.212. And then 48. And then enter. And if I hit enter again, notice that's 0.854. It's 1 minus that, or about 0.15. Any questions so far? Okay, so now I'm going to write down. Try this again. Okay, so the question is it statistically significant? The standard to decide if it's statistically significant is less than 5%. So what we can do is we can say that 0.15 is greater than 5%. Hopefully you all know that, right? So the answer is no. It's not statistically significant. So this is how they do studies. Whenever people do research and want to publish and say, I've got information that's statistically significant, we compare it. If it's in like social science or any kind of news, you use 0.05. So Celia asked, how do you know when to use CDF or PDF? CDF is for exactly equal to questions. PDF is for less than or equal to questions. So hopefully that makes sense. Any questions on this? Okay, would your answer change if you found out later that some students lied and actually 54 of them had used marijuana? So that's really easy. All we do is we go to our calculator. Actually, I don't even have to do that. Let me go second quit. I can go second entry. And then 54 was our number, so we're looking at 53. I hit enter. Little trick so you don't have to retype the whole thing. 1 minus 0.97 is 3%. 3% is less than 5%, so the answer is yes, it's now statistically significant. Any questions on that? I know it's a lot of information, but that's it for that chapter. We're done with the chapter. Ready to move on to chapter 5? Okay, so chapter 5 is a continuous distribution. So for continuous distributions, as I mentioned, that's when you can't list all the numbers. You're not going to be able to write a probability distribution table. It's not possible. Instead, at least for our class, we're going to draw pictures. Most people like pictures. So the ones I'm going to show you today, the pictures are going to be rectangles. Okay, so let me erase this. And let me put a new one in. Okay, so suppose the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. Okay, be sure to show your uniform distribution charts. So the first question I have is if a randomly selected math lab user is observed, find the probability the student will spend between 30 and 70 minutes in the math lab. So first thing, when you hear the word uniform, what should you be thinking about? Why do you have people wear uniforms? Any thoughts? It's not a math question, but it's going to lead into a math question. So why do you have people wear uniforms? That could be in the military, it could be in school, could be police, it could be, there's lots of places where you wear a uniform.
So
Why
they
do
look the same?
What's that?
So that they look the same?
Yeah, so they look the same. So we're going to be using that idea where we're going to say it's uniformly distributed if everything's the same. So if you think about a histogram where every bar is the same, then you just have a rectangle. Does that make sense? If every bar is the same height, it's just one big rectangle. So I'm going to draw a picture of a rectangle. Because it says I have to show my picture. Okay, that's my best ability to do a rectangle on a computer. Any questions so far? Okay, it's uniform between 10 and 120. So I'm going to label some things. So that's 10. And this guy is going to be 120. Any questions so far? All right, so one of the things when you have continuous distributions, probability is the area. Can you remember that? Forever. Probability is the area under the curve. In this case, it's a rectangle. Any questions on that? Okay, so what is the probability that if you randomly select a person that they're going to go between 10 and 120 minutes? It's a really easy question. That's a hint. Super easy. What's the probability if you randomly select a person that they, in the math lab, they're going to be there between 10 and 120 minutes? Yeah, 1. 1. Or 100%, but let's call it 1. Do you believe that? That's all you can be, so it's 1. So now what I want to do is I want to say, well, it's the area. What I don't know is I don't know the height of this rectangle. Is that clear? But what I do know, and I hope you all know too, how do you find the area of a rectangle? What's the formula? Remember, there is math in this class.
Length times width.
Yeah, length times width. I like to use base times height because L for length looks like a 1. So I hope you don't mind I'm using base times height instead of length times width. So I'm going to type in the formula. Very simple. Area is equal to the base times the height, which is b times h. Now the base is going to be how far it is from left to right. Well, if you're going from 10 to 120, that is going to be 120 minus 10. And then times h. Any questions on that? But that area is the probability, so that's equal to 1. And now I could just solve for h. Very basic algebra, but you are responsible for knowing basic algebra. If I take 120 minus 10, I get 110. If I divide both sides by 110, I get h is equal to 1 over 110. Any questions on that? So I can write 1 over 110 for that height. Okay, math is always easier to watch, just a warning. Doing it yourself is much harder. Okay, now the question is, what's the probability that a person will spend between 30 and 70 minutes in the math lab? So what I do now is I do some more sketching. So 30, I'm just going to call it, oops, I want to go to brush, my mistake. Let's go red. 30 looks around there. And 70 looks somewhere around there. And we want to find this area. So let's put in some numbers. Oops, what happened? Sorry about that. Try one more time. Okay, so now the probability that 30 is less than x, which is less than 70, will be the area of what we shaded in. And again, that's going to be the base times the height. The base is going to be 70 minus 30. The height will be 1 over 110. Any questions on that? Which, if you do that, 70 minus 30 is 40. 40 over 110, you get 4/11. And there's your probability. Any questions on that? Any questions? Okay, again, very different than the discrete probability stuff. This is area. Okay, so the next question, I have a second question. I think I'm going to have to erase the last one. Not that. I want to erase this guy. And let me pop it on in. Okay, find the first quartile for the time that students spend in the math lab. All right, so what we have here is we have basically the same picture. Let me erase what we don't need in this picture. And that was from the last question. So hopefully it'll let me do this. Get rid of that. Get rid of that. Do you remember what it means to be the first quartile? By the way, H is not the number of students. You can't have 1 over 110 is a tiny, tiny number, right? That can't be a number of students. It's less than 1 over 100, right? Less than 0.01. So H literally is the height of the rectangle. And in this case, it's small. It could be larger, but in this case, it's small. Hopefully that makes some sense. First quartile's first half?
First 25%.
Yeah, it's the first 25%. First 25%. That means the probability of being to the left of that is 0.25. So this is very different. In this case, what I'm going to do is I'm going to just eyeball about a quarter of the way out. That probability is 25%. So that area is going to be 0.25. Any questions on that? What we don't know is where 0.25 is. We know the area, we don't know the value to make the area. So when you don't know something, hopefully you know this from algebra. You call it x. Isn't that algebra? So now what we can do is we know that the probability is 0.25. We write down the equation and then we solve. So let's do that. So we know that our probability is going to be 0.25, but that is going to be base times the height. The base is going to be what? What's the base of this rectangle here?
X minus 10.
Yeah, it's x minus 10 because it's the distance between 10 and x, and that's x minus 10. Height is 1 over 110. And that is supposed to be the area, which is 0.25. Any questions on that? And now it's a beginning algebra question. Solve for x. So we're going to multiply both sides by 110. And we get x minus 10 is equal to 0.25 times 110. And then I'm going to add 10 to both sides. So let's do that. And we get x equals 0.25 times 110 plus 10. And what do you get? You should be able to do this in your calculator pretty easily. See if I can do it in my head. 520, 27.5, 37.5, does that sound right? You have a calculator, I'm just trying to do it in my head, so you can do better. Is that right? Don't trust what I'm trying to do it in my head, by the way. 37.5, good. At least we got one person agreeing. Okay, so I did get it right in my head. All right, so we go ahead. We say x is equal to 37.5. And that is the first quartile. Any questions on this? Any questions? Okay, just a note. If you have a uniform distribution, it's symmetric, right? So let me write this out. Since it's symmetric, the mean and the median are the same. Do you all agree? So the mean is the middle. And the way you get the middle is you take the average of the bottom and the top. So A plus B over 2. Where A is the low and B is the high. So you take the average of the low and the high, and that'll give you the mean. The standard deviation, I don't expect any of you to have any possibility of coming up with a formula for that. But you are responsible for at least having it on your note card. And that is going to be B minus A squared over 12. And it's a square root of all that. Okay, where again, A is a low and B is a high. Okay, so if you wanted to the mean of this will be 10 plus 120 over 2, which is 130 over 2, which is what, 65. The standard deviation will be 120 minus 110, quantity squared over 12. So in our case, that's going to be the square root of b minus a, that's 110, squared over 12. Which is, this one I can't do so well in my head. I can guess it, though. It's a little less than 40. See what you guys get in your calculator. So I do it in my head, I get a little less than 40, so what you get. I can't do it to too many decimal places in my head. 31.75? Okay, I believe that. It's less than 40. Again, I didn't stick it in the calculator, so I'm just trusting you. Hopefully you got it right. Hopefully I have a second on that. But it's a reasonable number, at least. Any questions at all on that?
I have a question.
Mm-hmm.
For the first quartile, couldn't we just divide 110 divided by 4 and then add the 10 to that?
You can do that, but I want to warn you. I could give you what is the 92nd percentile. Do you see?
Yes.
And then you're not going to be able to figure it out so easily. Does that make sense?
Yes. Thank you.
So I want to show you a process that's going to work for any percentile. First quartile is one I could give you because it's easy. And it also reminds you what a quartile is. But I could give you what is whatever percentile, some ugly number. So this way you can do anything that's given in terms of any percentile, whether it's the first quartile, third quartile, or 23rd percentile. Does that make sense?
Yeah, absolutely. Thank you.
Yeah, so yeah, you're right. That will work. It's a little bit easier, but it's not that much easier, it turns out. I mean, if you look at the algebra that I did, it was pretty basic, wasn't it? Hopefully you see that.
Yes.
Okay, what I want to give you now, I think I have room for it. Is the secret word of the day, or the week, I guess. And the secret word is area. So the secret word is area because anytime you're doing uniform distribution, it's all about the area. Okay, you draw the picture, you find the area of the rectangle. It's like the easiest formula you ever remembered from geometry, hopefully, and then you're done. Okay, so I am going to open this up to any questions. I think I'm going to stop share and answer any questions you might have. We went an hour and 19 minutes, so I don't feel guilty. I always say I try and make it between an hour and a half when I'm ready to answer questions and not talk about new stuff.
Just regarding our project, are you okay if we come up with a short list of potential topics and send it your way?
Yeah, better is to come up with your favorite topic. And I'll let you know if it works. And if it doesn't, then try a different one.
Excellent. Okay.
All right, so yes, a short list, but I recommend a short list of length 1. And that's better. And then, there's a good chance it'll work, and then you're done.
Okay, excellent.
There's a pretty good chance I'll have like a little refinement to do or something. But most people's ideas work.
Okay.
With the small modifications.
Thank you.
Okay. Yeah, and my way, by the way, this is important. When you say send it my way, how do you send it my way?
Email.
No.
Because you want it on the broad discussion board or project two?
The project
Project
one
one.
discussion board. Yeah.
Okay.
Because the idea is, and I've already seen people doing this, they're looking at other people's ideas and seeing what works and doesn't work.
Okay.
And that way everybody can benefit from my feedback. And you're also kind of reserving your project idea so other people don't take it.
Yes.
Okay, other questions? That's a good question. So again, the project one discussion board is where you put project one questions. The thing for email is things like, I'm going to be taking the test at this time on this date. Other people won't benefit from that.
Okay.
Okay. Personal stuff, that type of stuff, things that you don't want to tell people. But you should be fine telling people what your project idea is.
Okay.
Okay, other questions? Again, I'm always happy to answer any questions. And if you don't have any, I'm happy to say goodnight too. So other questions? And next week, by the way, is even easier than this week in terms of material, but you should be like deep into your project next week. And there's that test. So other questions? I'm looking at the chat box, I'm listening, not seeing anything. Heading over Target to get a charging cable for T84. Okay, good idea. All right, good night, Milgus. And good night, Elliot.
Have a good one, everyone.
All right, good night, Susie. And Cecilia. All right, have a good night. And for all of you who are watching this as an archived webinar on YouTube, thanks for watching. Don't forget the secret word is in there somewhere. And please post on the Project One discussion forum for any Project One questions and on the Q&A discussion forum for just general questions. And have a wonderful night.